Hello, this is Dr. Embody, and let's take a look at Project 4. All right, a few things to recognize here. Of course, you should start out by reading this first, but what are we going to do? We're going to prompt the user to select from a menu of options. So we're going to say enter a choice, and you're going to enter an A, a B, a C, an M, or a Q. Q, of course, will exit the program. And so here's our basic outline, and we're going to do some math today. We're going to do a factorial, we're going to do a sine, we're going to do a cosine. These guys are almost exactly the same, so it's like you really have to do two things. You have to do a factorial, and then you have to do some trig. And then you have to have an overall program that loops around through choices, but that's a lot like what you did in Project 3. Okay, so what's going to be done? Oh, we're going to have, so down here, A said we're going to enter an integer value of n if it's positive. Let's not worry about that right now because that's an error checking thing. We'll leave that to the end. Option B, we'll take a real value, that is a float, right? And it'll be in radians, this is not degrees, and it'll calculate the sine of x. And option C is the cosine of x, and M prints this menu. Just make a big string like that to print it out. So where did I start on this? I started just by doing this little thing right here. Okay, I made a loop that would exit from the program. That was the first thing I did. And then I went and I made something just like last time that would just do those choices. That's where I started. So even without doing anything more, let's start with, so what did I come up with? Well, you guys know how to do this now, but let me show you. So the very first thing I did was oops, we got a, there we go. I hit a wrong key, and let's see if this thing still works. It probably blows up. Enter a choice. So if I put in an A, it said I printed A. If I print in an X, it says I printed X. And it keeps going until I give it a Q, and that's all it is. I started just with that simple loop. You guys, the little while loop keeps going until I hit a Q, just like last time. And then we have some choices. So I then wrote one, and I printed out the menu. Notice I print out the A, B, C, D, and so on. And then it says input a choice. Okay, let's give an A, and it should say up here we're going to do choice A, and it will be a factorial. If I put in a B, it says choice B, I'll do a sine, and so on, and a Q, and it's still X. That's where I started. All right. Now, we're obviously going to have to figure these things out. So let's start with factorial. Okay, yeah, you can look up what factorial is. To do 5 factorial, what is it? It's 1 times 2 times 3 times 4 times 5, which is, if you do the arithmetic, gives us a result of 120. So what I did is totally separate. I just wrote a completely different program that does this. So I can't get confused with any of the other control and so on. I just wrote a program that would do that. It has one little loop in it, and that's all it does. So I then went and wrote a factorial program. And the factorial program says enter an n, such as my 5, and it calculates that the factorial of 5 is 120. And then I can copy and paste that, whatever it is, 5 or 6 line program that I have, into the part of the program where it says we're going to do choice A. So I just plug that in. So I construct this framework that all it does is, oh, we're going to do choice A, we're going to do choice B, and then I go off on the side and I write a whole program just so I can focus on that, get the factorial to work. Once I got that working, I can plug it in to my framework that I've created. And so how are you going to do a factorial then? Well, because it's multiplication, you'll want to start out with something like my factorial result starts at 1, right? And then what are you going to do? You're going to now take that and successively multiply that by 2, and then multiply the result, the factorial you get there, by 3, and then by 4, and then by 5. And now I'll have, that's how I can get 5 factorial. I, in fact, used a star equals in part of a loop. Okay, so I looped around and I had something star equals, and I started with a factorial 1, and at the end I printed the factorial that I had created. Right, so there's kind of an outline. We haven't talked, we've mostly done while loops at this point, but I can tell you that right now that this is ideal for using a for loop. Give it a try. Works pretty nicely. All right, so now that I've done that, we can actually take a look at the messier part of this programming project. And that is on the second page. Okay, so again, we look at the assignment notes here, and what do we see? Okay, the first thing is that it has to be formatted for readability. That's fine. It says program will detect and recover from errors. All right, we always leave errors to the end, so let's not worry about that. This one, number 3, is also talking about errors, so we won't worry about that. Number 4 is also talking about errors. We won't worry about that right now. If we and 5 says do stuff in the correct order. Okay, we'll just make sure we do stuff in the correct order right now. I'm going to skip down here at the bottom. The very last one says what to do when x becomes quite large. Great. We'll only deal with little stuff right now. And this one says just don't use those in your calculation. So that gets us down to 7 and 8, which are really the core of this whole thing. And in fact, we're not going to worry about half of this, because this first part is about sine. I didn't draw that very well. And the second part is about cosine, and it's almost exactly the same. So let's ignore it for right now. Right? And then finally, this number 8 is actually kind of important, because it says that when we do our while loop, because we're going to have a while loop here, that we're going to have terms, and the absolute value of the term that I'm doing, we're going to keep going until it gets too small. So we're going to keep going as long as it's bigger than this particular value. And so I'm going to have to, in order to do that, I'm going to have to calculate each term, and then I'll loop and do some stuff. But that's what this is telling us. So then we can focus on what's going on up here. All right, so the sine of x is, it's x cubed over 3, x5 over 5 factorial, x7 over 7 factorial, x9 over 9 factorial. And notice how it's a minus sign, and then a plus sign, and then a minus sign, and a plus sign. But it turns out that each one of those terms, and these are called terms, each one of these guys is a term. That's the first term, the second term, the third. Right? Those are all terms, the same term that I was talking about here. Here's the formula for each one of those. And one of the things you should do with pencil and paper is convince yourself that this works. Okay, when k is 0, it's -1 to the 0, and then x to the to 0 plus 1 if we're starting with k of 0. And then we have a factorial, 2k plus 1 factorial. That's the first part of your program. Now, remember, if you've got that factorial program working now, you're going to just copy and paste it in here. So you want to, so this formula here is just a collection of these guys right here. So this is your focus. This is what you're doing in this part. That's really what you're doing right there. So you need to make a series of these and add them up. And since this is addition and the additive identity is 0, then you'll want to start with my value of sine being 0. You will then calculate each term. That's a term right there. And then you go into the loop, and what are you going to do? You're going to do some calculations in there, including a factorial, and then you will just say that your sine, just add your term onto the sine. And that's the basic idea. And what do? You write a whole separate program. Forget about everything else in this project. Just write a program that'll calculate the sine. And in fact, I even started with something else. I started with a little program. I imported math because we're not allowed to use math in here, so this is just during development. I defined that that value that we use, this 1 e to the minus 8, I defined that as a constant. Okay, so I had that value there. I put that in. And then I said, then what I do next? I said, input an x, and then I just calculated the sine of x. Just, this isn't what your program's supposed to do, but I use this as a way to check that I'm getting the right value. So my code will calculate a thing I called sine and print it, and then I will check it with my math.sine. And a lot of this stuff is going to disappear in the final program. Like, I don't need import of math anymore, and I'm not going to have the check in there at the end, but these are very handy when I'm developing the program. So this little guy here, if I run this, it says input an x. Well, I need to have some kind of an x. And a nice one, the one that my dad taught me, is that the sine of 30 degrees is 1/2. And what's 30 degrees in radians? Oh, that's pi over 6. And so when the result comes out, that should be roughly 1/2. How do I find what the sine of pi over 6 is? I'll import math, and I will take math dot pi and divide it by 6. So let me just stop the program here for a moment. Import the math, and math dot pi over 6. There's the value that I'm going to work with. So with that, let's fire up my program again. Input an x. I'm going to input this x. And of course, when I check it, it comes out with 0.499, which is roughly 1/2. And so that is my check. Then I can go and write my actual program. And when it says input an x, now it will actually calculate it. All right. So I put the code in to calculate it. That is doing this stuff. All right. And then once it is calculated, I check it with the math. And you see it's off by a little bit in the final digits, but that's just because their approximation for sine was a little bit better than mine. That doesn't matter. These are close enough for us. So this is basically giving me that the sine of pi over, this is basically telling me that the sine of pi over 6 is 1/2, and that's what we want. And so I wrote this as a separate program, and then once I can do the sine, I can plug that into that framework I have, and oh yeah, once sine is done, just copy and paste, because there's just a little bit of difference. This term is exactly the same. Instead of 2k plus 1, I have 2k plus 1 and 2k. So the code for cosine is almost exactly the same as sine. So the hard part of this project is this. And just write it as a separate program. Write it as a separate program, get that working right, and then you can go back and take care of the erroneous input, and then you can go in and this stuff about the large values. You can plug all that in later on, but remember, do this as separate little programs, and that's where your that's really the way to do it. Remember, inside of every large program is a smaller program trying to get out. In this case, you've got the factorial program to write, you have the sine program to write, and then after you've got the sine program to write, the cosine is like a 5-minute thing. Make a couple of little changes, copy and paste, boom, we got it done. That'll do it.